fan is the one which is then pushing the, I will like to push this on. Can you see the full screen now? Can you see the full screen?
No, no.
No.
So अभी मैं, what do I do now? Can you see it? Maybe there is a time lag. Wait for some time. No?
No, not yet.
We can see your cursor moving, so time lag is not a problem.
ಇಲ್ಲ. Lakshmikant bhi na barabar. Yeah, they can't see the full screen yaar. Full screen. શું કરવાનું બોલો હવે? આના કરતું તો ઘરે મજા આવે. Now can you see? If not, then we'll do the, you cannot
No,
see the full screen yet.
no, we cannot. We
How
cannot.
is that possible? But sure. ठीक है, चलो, whatever it is.
Do you want to try it from the lower this thing, the icon on the right bottom corner?
Uh, what is that?
The full screen presentation mode.
That's what I did. I did that only. So if I press this, it will go full screen, but then it's not happening. I always go from here. मुझे वो slide वाला नहीं जमता है. Anyways, guys, so whatever, your luck. So this is the differentiation between the chilled and the direct expansion system. So obviously, chilled is for a larger area because water is very easy to push. Okay, plus it takes a lesser time as well as lesser space. So what it makes more sense that if I have a very long, tall building, then I would go for chilled water system. That means tall building means more space, means more cooling. If there is a large capacity cooling required, then you would go for chilled water. जब छोटा चाहिए, intermittent चाहिए, on and off वाला, then you would go for direct expansion system. Okay, obviously larger area you will go for chilled, smaller area direct expansion. But again, guys, don't get confused by smaller area. That's why I already discussed factors of deciding your AC. It's not just the smaller area. Say you have a small area, but it's something like an important lab where you have to maintain the temperature. ऐसा नहीं है कि 7 बजा कि चलो घर गए and you have to shut off. Now, even if it is a small area and the entire thing requires dire cooling for some experimentation or some scientific thing that is happening inside, then you would still need to see to it that it gets chilled. And if the tonnage is higher because the entire laboratory is to be done like this, then you would go for something like chilled water. Okay, but then of course it depends on the tonnage and everything. So air. So what I'm saying is, be aware of what and why you are doing it. Do not just jump to the conclusion कि हाँ मीनल ने ऐसा बताया था और हमने ऐसे किया. ऐसे नहीं होता है. You have to take lot into consideration before you decide what it is that you actually want. Uh, chill water. अच्छा एक सेकेंड लक्ष्मीकांत जी इनको they cannot see the full screen. क्यों? फुल स्क्रीन किया ना. अरे मुझे पता है फुल स्क्रीन कैसे करना, पर उनको नहीं दिखता है फुल स्क्रीन. क्यों? नहीं, they are not able to see full screen. हाँ, everyone is there. अरे उधर भी नहीं चल रहा, उधर तो कंप्यूटर ही हैंग हो जाता है. और भी मैं दूसरा तीसरा नहीं चेंज करने वाली हूँ, सॉरी. ऑलरेडी मेरा 10 मिनट गया इधर से इधर आने में. यू कैन सी द फुल स्क्रीन गाइस? कैन यू सी द फुल स्क्रीन?
No.
No.
ओके फाइन. फाइनल, आई एम नॉट गोइंग टू डू इट. ठीक है, ठीक है, चलो. सो वी आर हियर. So this is the AHU is a necessity in a chilled water system, and we'll study what is an AHU. Next topic is that, I guess. And then no, the third PPT it has. And you don't require an AHU, but this is where I left last time. AHU again is a possibility in a direct expansion system. So imagine KJ, you have an auditorium which is in building number 1, but your basement is not there. The basement is happening in building number 1 for whatever reason. Okay? Maybe the buildings are very far apart and the geological component below the building 2 is not giving you the access और easy permission for basement. So आपने सोचा हम basement 1 में बनाएंगे और 2 में नहीं बनाएंगे, and from there you have to traverse all the way to the building 2 because your Audi is there. Now that means the distance has increased. Okay, so first thing is you would go for VRV, but suppose that is not an option, and you want to go for direct expansion system. In such a case, what will happen is the refrigerant will have to travel long. When I have to travel a long distance, okay, I would introduce AHU in it where I can give the cooling coil in between somewhere, and then from there the air is passed over. So I will not put AHU right at the auditorium. क्या ज़रूरत है अगर रेफ्रिजरेंट को उतना ही आना है तो प्रॉब्लम है ना. So I would then introduce AHU somewhere in between where the cooling is transferred through the air and the refrigerant do not have to travel so long. That is the otherwise, as I told you, larger the distance, larger the friction, and as we all know, refrigerant is highly volatile. uh, जल्दी से अपना phase बदलता है. It takes little bit of water, little bit of heat, and it can turn into different state, which we don't want. So, or we want to happen only in the required space, not in between. So that's the reason why you can have AHU in between where this transfer can happen. Chilled water is circulated to AHU from AC, and यहाँ पे क्या होता है, chilled air is blown over the coil and taken to the required space. No bulky ducting from AC plant room. Easily एक छोटा सा तुम्हारा chilled water का pipe is coming up, and you are done. But in this case, you will have huge fan which is making terrible noise. Okay, and then you will have tremendously large duct emerging from the plant room, taken all the way to the place where you want to cool the air, cool the space, and so that means the whole false ceiling will have to be planned. Suppose if it is going through corridor to corridor, maybe if it is a high kind of a say you are making some nice embassy or something like that, and you have an auditorium. Now imagine you taking the ducts through the passages and through the lounges and everything. So imagine the kharcha that comes overall, the space that is required, the kind of pushing of air to all that long distance. So yes, guys, it's tedious. Okay? Carrying air, a large amount of air over a long distance is space eating, cost eating, energy eating, everything. That's why chilled water works in a high-rise building. Huge ducts are used to carry cooled air from the AC plant. Air is cooled at the AHU level. यहाँ पे air is cooled at the AC plant room level, because here I am not using the chill water at all. So this is how you will be distinguishing between chilled air, chilled water system, and the direct expansion system. Okay. Now the next is the unit systems that we'll be studying. The unit systems are many. One we know is the window, which I already explained to you, but you can see from the diagram here, सब कुछ इधर है. एक छोटे से बॉक्स में पूरी ज़िंदगी उनकी है. यहाँ पे पूरा संसार उनका वो छोटे से बॉक्स में है ऑफ योर AC. So it has condenser, it has evaporator, it has expansion wall, it has compressor, and a fan. All those 5 components यहाँ पे तो chill water there is no possibility, right? You can't put chill water in a room. So all you get is a cool air, and that cool air is nothing but a fan put in right in front of your evaporator, which is pushing the air over the chilled coils, and that in turn cools, and you get a cooler air or a chilled air. Then your question is, should there be another fan over the condenser so that the condenser will be? So that's the reason why the box is so big. It kind of hangs out of the window, and it utilizes the air that is moving around, okay, and it dissipates the heat that way. So there is no separate fan used for the condensers in the window unit, and that's the reason why, guys, window units fail. Hmm? Because you can imagine a window unit at a ground floor. Ground floor में in Mumbai, and you have your 6 feet के distance पे दूसरा building खड़ा है, कहाँ से air आएगा? So sometimes, because the condensers are not cooled well, your gases do not chill well. As long as the heat is not dissipated, cooling will not happen. So that dissipation of heat is of prime importance for you to get the correct cooling that you are looking for. That's why we then call the guy, and all he comes and does is put a fan there, condenser cool hota hai, and it starts working, and he charges you $1,000. Okay. But these are the simple facts, okay? Where the AC unit or the window unit has failed big time. The other disadvantage is it needs maintenance, so people will walk in and you are working there, it's an office hour, and yet the guy will have to be at that room because that is the place where the entire unit is. So yes, the disturbance at the work level, there is a lot of sound that is there because the fan भी है और compressor भी है, दोनों ही बहुत आवाज करता है. So there will be too much of noise. So a constant humming sound comes there. It's the productivity. There was some surveys done in US that how the AC system can mar the productivity, and it really was a very high factor when people answered that yes, it's a very constant irritation of that sound, and actually they breathe a kind of एक सुख की सांस लेते हैं जब वो एसी बंद होता है because it can be quite terrible. Uh, and advantage is that easy to sasta hai, not so very costly, can be easily controlled, and easy for installation as well. Okay, I don't really have to invest so much. But when I talk in terms of energy, absolutely nothing in terms of energy. Now what they have done is, so split units, you might have seen some ads where they say 5 star, 4 star, 3 star. So these are the ads which tells you, or these are the techniques which tells you that 5 star will be always costly. But the idea is the amount of energy they save when you see the yearly kind of saving that the energy goes through will be quite high. So that's how they manage this thing. So that's why they say that if you buy 5 star, the running of the instrument will be at a quite long time because it's saving a lot of energy. Okay. So this is your window unit. Any questions here? I'm sure none of you have seen it because it's now not available. Mostly it is out. Okay. What you get in the market is the split units. And that is, so this is how the window unit looks like. Okay. Where they have kept it outside, but this is basically the, sorry, yeah, wrong. Okay. This should be actually split unit. Components of split units. Split units are also independent units, but यहाँ पे you can see that this is where my entire fan is there and the evaporator is there. But my compressor and the condensers are placed outside. Okay, so the refrigerant travels to and forth from the evaporator and the condenser via compressor, or this is kept outside. They may have kept a fan here, but it's not needed actually because this dabba can happen on a ledge of the window, or it can be, if your building is just G+2 and you are, suppose you have a terrace flat, so terrace is not very far off, so you can actually put your dabba on the terrace, so where you get plenty of air. So that's how the split works. So what happens in a split is, uh, of course, it can be controlled easily. Definitely, that is an advantage. It creates comfortable ambience because this, none of the parts here. That means a silent kind of a fan that they use go for, and evaporator don't make noise. The main noise making, that is a compressor, that is a pump that goes up and down all the time to compress the air, which really creates noise, is thrown out. Okay, so you get a kind of a very silent, no humming sound basically. Okay, does not block the window for light. यहाँ पे second thing is, why do I have to keep the split unit? I can keep anywhere, na? I can, like what we have done in the AV room, what we have done in the computer room. Okay, it's there on the wall. I don't need to cool. Because what are you cooling? Nothing. You are cooling the air inside. You don't need to cool the condenser. Condenser तो बाहर है. So that means you will not need to block your window. That's the advantage of a split unit. While in window unit, no matter what, you have to keep it at the window. Otherwise, तुम्हारा condenser cool नहीं होगा and the AC will not work. And definitely, it's a unit system, so you can go and buy as many as you want. You can sell as many as you want. Okay, second hand, and so it's easy, cheap installation, not much investment cost. Okay, but yeah, year after year, months after months, you pay the bills. Hmm. Yep. The next one in line is, so this is how your split.
Hello, Minal.
Yes,
Yeah, I had a doubt. So
yes.
where do we usually use the split units? Like, when do we use window unit and split unit?
हाँ, so window unit, my dear boy, is not available now. तो तेरा वो टेंशन ही गया, हाँ, अवेलेबल ही नहीं है. Because as I say, they are not environmental friendly. And plus they kind of create problems with humans. Okay, we don't like so much of sound, especially you're working from, imagine karo to you're working in an office from 9 to 5 and you are hearing that sound. Okay, it can be very irritant. So people have faced major problem with that, so it's out. Split unit is basically, so you have an office, हाँ? जैसे आपको you guys did multi-purpose hall in your third year, right? For that community, fifth semester में आपने किया. So you guys
Yeah.
had a multi-purpose hall, which many of you opted for nice and ventilated this thing because we never taught you AC there. But suppose अगर वो AC होता, that entire multi-purpose hall was an AC thing. अभी वो उसका area was around 100 and 150 square meters, okay, which means that you will have to go for a small, larger system. There you cannot go for a multiple split unit. I mean, you can go, but can you imagine your interior? 1, 2, 3, 4, 5 on this wall, 1, 2, 3, 4, 5 on the other wall. है ना? Suppose you require 40 tons. Suppose you require 40 tons to cool that air. Okay, and we'll do the tonnage. But chalna, let's calculate. Since you asked this question, chal. So you guys had a height of 5 meters. Chalo, most of you guys had a nice height. Okay, chalo 4 meter लेते हैं. And your area was 100. कितना हो गया तेरा volume कितना हो गया? 100 into 4, 400. है ना? This is square meter.
Hmm.
बराबर है? Convert that into feet into 10.6 या 10 ले ले for easy calculation. So 4,000 हो गया. 400 into 10 is 4,000. What was the tonnage? Every 1,000 1 ton.
Yeah.
Again, so ये तो तेरा
Hmm.
400 into 10 is 4,000. You will require 4. So actually you can go
4.
for split AC. Yeah. हाँ.
Yeah.
Am I right or wrong? 40 ton कैसे नहीं? 100 square meter है is 10 by 10, right? 100 square meter into 10. Sorry, guys. Cubic feet is not 10. Multiply करो कितना होता है? Figure it out how much it is. My mobile is there. Let's do this calculation right now. What is the conversion ratio? Cubic feet to cubic this thing? Cubic meter to cubic foot.
It's 35.3.
Yeah, so now multiply 40, 400 into 35. हो गया ना? So you will require
Hmm.
so many split units. Now the question is, so many split units will have so many outdoor units, and that you will have to take it out, and then the entire elevation can be marked. So when you go anything about 20 ton, suppose you require anything about 20 ton, you go for package unit. If your area is like, suppose you have a green room, so you decided that okay, this is 20 ton and I'll go for a package unit and I'll have a ductable package unit. But now green room ke liye, why will I have a package unit? So there I can go for a split unit where individually जैसे the ladies room का पहले उनका performance है, so they will come out, they will perform and they'll go back and they go home, and while they go home they shut off the AC and they go home. So that become individual controlled small spaces. I will go for split unit. Imagine your
Yeah.
our college. ठीक है, अपना कॉलेज इमेजिन कर, वेर वी आर प्लानिंग फॉर एंटायर सेंट्रल एसी. भगवान ना करे कभी ऐसा दिन आए, बट सपोज वी डू दैट. हाँ, सो स्टाफ रूम इज अ बिग प्लेस, लाइब्रेरी इज अ बिग प्लेस, योर एवी इज बिग प्लेस, कंप्यूटर तो यहाँ पे तो है ही. Now imagine these 4 and plus fourth year in between, and we all have this centralized, okay? But we know that Paul's room or right now Manoj room, Manoj kabhi rehta hai, kabhi nahi rehta hai. So why should we? And it's only for one person, okay? And while everybody is using every other space, that room he is never there. Okay, he is roaming around because he's taking class and he's going out and he's meeting people and he's not there. Why will I centralize AC there? So there I'll use a split AC where he can control it individually. So that's where I will use a split unit. Did I answer your question? Thoda lamba tha, but did I
Yes,
answer
yes,
your
yes.
question?
Yes, yes, yes. Got it. Got it.
Yeah, so this is how my split door works. Okay, so indoor is blue, the outdoor is red. Red means it gives out heat. That's why I place it outside. So compressor and condenser is outside, evaporator and fan is inside. So this is my split unit, और वो ऐसे दिखता है. And what you see in your room is just this: louvers, condenser coil, and a fan. The rest is out. This is also not available in the market today. ये भी नहीं मिलता है, but since it is there, based on ductable split unit, तुम्हारा VRV system is planned. Remember this, when we discuss the VRV system, it is based on this. Split is where you are capable of splitting the unit. The VRV also functions like that. They are able to split the unit so that you can control each and every area. So that is the whole concept behind VRV and ductable split. But in today's day and time, we don't have but ductable split unit, because what they have done is the tonnage is 1.5, 2, 3. That's it. 5 you do get, but hardly anyone. Why do I don't get a 5 ka ton? Can you imagine, you are sitting in a AV room. AV room में 1, 2, 3 on this side. दो है कि तीन है? Anyone any idea? I think there are 3, है ना?
There are two
And
on each side.
2 on each side. चलो. So there are 4. So there are this 1, 2, 4 का है tonnage. Okay. आपने बोला हम 3 का एक साथ लगा देते हैं. We'll work where I want to have a nice space. I don't want to clutter the space with too many split unit. एक second. Hey guys. Hello. लक्ष्मीकांत थोड़ा धीरे बोलो ना. Where was I? Yeah. So you say that I don't want to clutter the space with too many units there. Okay. I एक 3 का लगा देंगे, काम खत्म. हाँ, जाने के टाइम एक ही लाइट बंद करने का है ना. So you are thinking like that, but imagine the guy who is sitting there, right? नीचे 3 के, वो तो उसको शॉल लेके बैठना पड़ेगा. Okay. Because maximum air will be thrown there. So it's not ideal. Okay. So imagine the same thing happens in your hotel room, where you say that ठीक है एक रूम है हम ज़्यादा लगा देंगे दोनों को काम करेगा. It never works like that. That's the reason why the ducts came into the being. Okay. So 1 ton, 1.5 is very easy, tolerable for people to take that kind of chilling. Okay. Beyond 2 to 3, you will need ducts. So that's the reason. Unless the area is very large, है ना, आपका कोई शॉपिंग मॉल है और आपने वहाँ पे 2 का लगाया, तो then ठीक है, because you are not sitting there under, है ना, आप मूव कर रहे हो, you are moving around, then it's fine. But if it is like a classroom or a conference room or anything where people are sitting there, problem. That's the reason why you have 1.5 very popular. Uh, that's the reason why ductable split units stopped. So this is these are some of the ways the AC has developed over a time. Okay? Any questions so far? So far, the same thing is happening here. What they're doing is, this is the outside is throwing off the heat in all direction, while this is the cooling, and you are using the duct. So this is the top floor, this is the bottom floor, and that's how you are doing it. Okay? This was when the split units were possible in the range of 5, 10 tons. But now they don't do that. Instead of split AC, what they have done is they've gone for something called as a package unit. Okay. So this is what they have gone for. So package unit is nothing but a big brother of window unit. Okay. Split may we were splitting. Package may you don't split. You get the sound, you get the heat. Sub package में मिलता है. Okay. Now that is the problem. So again, what you did for your window, you will need to do for your package. You will need to give me a external wall with a nice kind of a ventilation, so that I can cool off my condenser. Okay. That's one way of doing it. Okay. And Chotu Save also, I need 25% air inside, because this is now kind of a mini centralized kind of a thing, where I am circulating air to a larger volume of area, and that needs the input of fresh air inside. है कि नहीं? So when I want that, what I'll do is I'll put my package unit near a window where it can take that 25%. Now cooling of condenser, if you expect that वो एक छोटा सा window से आपका cooling हो जाएगा, तो वो एक myth है, वो नहीं होगा. So again, you will either have to put a fan there, or you will have to use the cooling towers. So whatever it is, you will have to cool the condenser in a right possible manner, which we have already done. Okay. So yes, condenser, the package unit will need to have all these kind of uh, components that we already studied with. Lekin, the rest is everything same. The change here is I can use ducts here. And since it's a 20 ton, and you have a large community hall that you guys designed in your 5th semester, you can actually allow the ducts to run like what we saw in the mechanical ventilation, where I showed you the ducting plan. You can have a central duct, you can have the supply duct, you can have the return duct, and you can take it out. Okay? Same thing will happen, same configuration. You cannot have the distance between the diffuser and the grill to be so nearby कि एक जगह से एयर डिफ्यूज होता है और दूसरी बाजू वो सक आउट होता है, आपको तो मिलेगा ही नहीं. So you have to take care of the short circuit of air and all that. So the minimum distance between the supply air and the return air grills will have to be 3 meters. Okay? So, and based on that, you will do your configuration and layout of the ducts. Is that clear? Any questions here? So you can see from the diagram, you have a condenser, okay? And you can say that the condenser air cool weather. So they are using fans here, okay? And that means that they will have to take, again, put a big duct and take that hot air outside. Then you have supply air fan. So fan आपको push करता है. So it supplies your fan here, and somewhere here is your cooling coil, okay? So this is how actually ये outdoor air है, ये return air है, then it cools. Then you have, actually fan should be behind, not here. Hmm? Otherwise, how will this work? So the fan should be here, and then it pushes over it, okay, and then you get supplied. So that's how it is. Okay. Any questions that you didn't understand here? It's the same as your work as your window unit, except I can do the ducting here. And in window unit there is no 25% added here because आपका दरवाजा खुलता रहता है ना, आप तो you are in a bedroom or a living room where you apply that window room, so obviously it's not airtight. And same thing will happen even here, but still, since it's a larger volume, and say you are in an auditorium में once the show starts, nobody comes and goes na, as often as one would do in a living room. But so that's where I need to infuse 25% of fresh air inside. That's the reason. Hmm? Okay, can I go ahead? Okay, so this was it. Next one is again. So this is how the package unit works. Okay, in 3D it shows that somewhere here is my package unit. So it's placed on the top, and from there you can see the ducting is done. So each level of the house gets the AC. Okay, and this is where the cooling also happens. So ideally, this would be the best place to keep if I'm not thinking of environment. Okay, and even if I'm thinking of environment, it's so easy for me to connect the condenser to a nearby cooling tower, है ना? छोटे से छोटे distance में मेरा काम हो जाता है. So I am saving lot of money instead of traveling that hot water all the way up to the cooling tower and all that. I can place my entire system on the terrace as a package unit, and then all I have to do is the transfer of chilled air. That is also environmental friendly because chilled air is automatically settle down. वो अपने आप gravity से ही अच्छे से जाएगा. You will require lesser pumping, है ना? Because chilled air is heavier, it will tend to settle down. So that also works well. So in a way, package unit to be kept on a terrace is a win-win situation. Yeah. But people don't do that because it mars unless you plan your terrace well, unless you plan your elevation well. So that's how it is done. Okay. Another example where they are keeping it down. That was on the top. This is at the down. The same thing. Okay. But यहाँ पे क्या करना पड़ेगा? They will have to take a pipe up and put it to the cooling tower. But since they are not using the cooling tower, that means इतने बड़े घर की गर्मी is directly released outside. Okay, very inconsiderate according to me. Okay, you are just heating up the space around you, unnecessary, creating lots of problem for the other people. This is another way. So this is how it looks. This is basically to give you an idea about how does the package unit looks. It actually looks like a huge cupboard, literally. Hmm? It just looks like a huge cupboard which you can place it in a room. Okay, and package units are of 5 tons, 10, 20. So if you say you require 15 ton, so you can do a combination of 10 and 5. You require say 30 tons, so you can do a combination of 20 and 30. So 40, 60. You can have triple kind of package units. So it's easier, it's very easy for me to maintain, and instead of a huge direct expansion system which is like takes up huge space and all that. So it works that way. So these are the different ways package unit has been known to be very useful and can be a kind of a replacement for the direct expansion system. Hmm? So this is basically just telling you that this is how it looks. Okay, this is water cool package. यहाँ से पानी जा रहा है wherever it is going. Okay, and this is where your cooling tower is. Okay, and that's how the thing comes back. Okay. So this is the makeup wall that I was telling you about. Makeup wall is nothing but allowing the makeup water to come inside. जा रही है, bye. Yeah. And then this is the reason why I was telling you that you require 50 square meters to 100 square meters, kind of, because you can see the scale of the machines that are being used. So this is definitely a chilled water system used where the tonnage could be go around 100, 120, 30, 40, whatever. Okay. And then these would be your compressors, condensers, chillers, everything into one thing. Okay. And these are then various sensors that is applied on each and every apparatus that comes out of the unit so that everything is sensed. Okay, just today I saw a very beautiful TEDx video where this lady, she's an architect cum planner, she's talking about smart cities and how applying smarter technologies can help cities to be highly sustainable. So Singapore is going smart city. In fact, I would say smart nation because they are very busy collecting big data. You know what is a big data? Big data is this. Big data means knowing the flow of people, flow of element, flow of traffic, flow of everything. Huh? And then you can actually match and then create, so you can save time, you can save energy. So just one example that she gave, and I found it really fascinating. I would just like to share that with you. It has nothing to do with AC, but so she was saying, "Ki, how do you think big data will help make nation very smarter?" And one of the examples she gave was, say there is a building which is using this big data, and imagine just not a building, but the buildings are then connected to the traffic zones, traffic hubs, and sending out signals that these are the times when the whole lot of people will come out because the office hour gets over. And as soon as that data is received by the transportation hub, the number of buses that is released in that area will be frequent and faster and of a higher capacity. So, तुम्हारा mass transportation becomes easier, people don't have to wait, and your transportation in cars will come down, and that's why the pollution will come down, your fuel use will come down, and you are saving energy, win-win situation. Amazing example that she gave, and they are saying that they are trying this in Singapore. Uh, अगर वो video just type smart cities, really amazing video, and she gave some amazing examples of how smart cities can be made by using smarter technologies. And when I use the word smarter technologies, is exactly what this guy is showing you. This is known as a sensor where it senses what is the temperature of the refrigerant, how much is the quantity of that refrigerant being passed, what is the flow and the velocity. Everything is sensed by it, okay? And this sensor is then related to the AHU. When the AHU पे demand आता है कि now I need higher kind of a supply, the AC plant room will start working higher. So that's how the transfer of information happens digitally and helps you to control. And that's why everything is now remote. पहले खड़ा होना पड़ता था आपको and actually have to turn the knobs, to increase the flow of the refrigerant so that you get a higher cooler air. But abhi everything happens with remote. So these are some of the things that one needs to keep in mind and keep this reality check with you. Understand the sizes and spaces that you will have to design when you're going for centralized AC. Hmm? The some of the difference that was between the chill water and the expansion system. This is the between the centralized system and the decentralized, यानी कि unit system. So use for larger areas, simple है, and use for smaller areas. Centralized is used when continuous air conditioning is required. That means a very high tonnage is required. While here intermittent cooling is required, then I will go for a system that is unit based, where I can turn off, I can be individually control it, save energy, be more aware of it. In a centralized, you really don't give a damn because you can't control it. है ना कोई control होता ही नहीं है. You just leave the room, and that's where the sensors again will come into the picture. Large area is required to house these systems that we saw. AC plant rooms, AHU, CT is your cooling tower, and the other accessories, meaning all the pumps and everything that needs to come there. While in a package unit आपको कोई accessory जगह की ज़रूरत नहीं है ना. So suppose if I'm using a package unit, I will require a small room where I can house that cupboard of 20 ton. Suppose 40 ton का है तो मैं दो cupboard का जगह बनाऊंगी, okay, and I'll give a window and I'll give a cooling tower and my thing is done, okay. Is this package unit very tall? No, it's not. It's like a cupboard, okay, like a Godrej का cupboard आता था ना पहले के ज़माने में, बस same size, okay. So something like that can be very easily managed in a smaller space, okay, and gives me around 40 to 60 tonnage. यहाँ पे in a centralized, imagine a pump not working for a chill water system, so you will require standby. And एक नहीं, you will require booster, तो booster का standby, jockey तो उसका standby. Every time you have any instrument put in a centralized system, आपको उसका standby लगाना. That is another reason why the room sizes go so big. यहाँ पे no standby, okay, because package unit works at that level. Okay, you have a fan and fan will work. Yes, if there is no electricity, AC will not work without electricity. आप उसको generator पे नहीं डाल सकते हो. Also, I use generator for safety purpose, not for comfort purpose. So definitely ACs will not work when the electricity is not there. So I don't require a standby fan then, okay, where which will you say that this will be then used on the generator, doesn't work. Huh? Planning is required to install these systems. Since they are very large areas, since they require tremendous maintenance and look into kind of affairs, I need to plan them. Okay, it cannot be randomly placed. You will need to see that AHU comes one above the other. AHU comes above the AC plant room, taki your transfer of pipes becomes very easy instead of running around in the basement before it finds. Acha, yahan pe AHU and now I need a cutout here, so I'll go up. The ducts don't have to think about that, right? You just one above the other, and like a toilet, the ducts will work fine. Doesn't have to even think about it in terms of package unit because package unit works for the same floor. But package unit can also work as I showed you in the previous pictures, one above the other. In that case, you will have to give the duct. But if it is a split unit, window unit, you don't have to think about duct at all. Installing secondary equipments for the air and the water distribution. So yes, you will require water pipes because drainage is a big concern when I'm talking about, and I told you about the Burj Khalifa thing, right? A tremendous amount of water is condensed and that condensed water is then collected on the room, which will tend to become very wet and ugly and mossy and slippery, and we don't want that. And so it needs to be drained very nicely. No secondary equipments required, okay. But having said that, unfortunately, you can see that every building has this problem. Most of the building, when the architects plan the building, even in today's day and time, they do not plan for the ACs to be kept there somehow. Abhi I don't know why. So what happens is once the people come in, they will want to put the AC. Now they put the AC. AC रखा, अभी डब्बा बाहर आएगा. So obviously it basically destroys your elevation. Forget that, okay. But what happens is they have not planned the condensation water to be taken out. Now, if you have noticed in your own home, and if you can do this as an experiment, put the draining pipe inside your room in a bucket. If you use the AC from evening 10 to morning 8 o'clock, one whole bucket of water is filled. है ना? Now imagine there are 40 flats in your building. Now that means there is 40 buckets. Now all that water is what is happening since the builder has not planned, the architect has not planned. वो सारा building का पानी मतलब you can actually see the black lines happening on the building facade, which is ugly, which is dangerous because over a period of time your plasters will crack and the leakages will happen. Okay. The second thing that you notice is that tap tap tap, that sound that happens. अगर नीचे किसी ने छज्जा छज्जा लगाया है पतरे का, ऊपर से आपका एसी का पानी नीचे गिर रहा है, and that sound at night 3 o'clock is so irritating. Okay. So that is another thing. So yeah, and the third thing is your entire ground floor area in the morning is wet. So yes, so this is a problem one has to encounter when you are planning for decentralized. Unless you have to be, you plan your building sensitively, ये problem reoccurring है. Large constructional installation and operation costs are involved. Obviously, you saw the machine and the space and the kind of systems that are there. While here, it's very affordable. You go and buy, spend 40,000, and a split unit is at your place. Okay. So that's how. While if you have to plan a package unit, I mean, sorry, if you have to plan a central AC, the cost can go minimum around 4 to 7 lakhs. It is that costly. Maybe more if it is a higher tonnage. Difficult to control areas if on a centralized system. Okay, but now with the new technologies this is possible, but up till now it was a real issue. The very basic methods of damper system was used, and I'll show you that in a zoning when we do the zoning. Okay, so it is possible now, but still it is not as good as it is in a decentralized system when I walk out and I close the system and I'm controlling it. Okay. Central system equipments have long service life. While obviously, you know, a unit system को हर 6 महीने में आपको उसको update करना पड़ता है. I mean, maintain करना पड़ता है, and it lasts basically 5 to 10 years, and then it's out. While a centralized AC, you can relax for 20, 30 years, no problem. So that is how the difference between the centralized and the decentralized, यानी कि unit system is there. Space is required for AC installations. Obviously, you have HVAC system requirements में क्या क्या आता है. Primary में आपका आता है heating equipments, cooling यानी कि your AC plant room basically, where evaporator and your condensers come in, and your air delivery requirements, meaning all your ducts, all your pipes will need to be taken up at that level. Equipment rooms, installation, these are space requirements for overall this thing, and then finally your air distribution, and then the piping. All these will require things like cutout in slabs, okay, grills and diffusers for air distribution, plus the false ceiling and how the ducts are being taken to the rooms, and where will the ducts, the grills and the diffusers will be planned. So your RCP will become a very important factor. Everything, right? So when you become an architect and when you get a project, it's not just about the form of the building and I'll get a good ho-ha about it. It's not like that. No? As an architect, your primary interest should also be the user friendly and a user loving space, right? People should love the spaces that you design. Now, when you want that to happen, they have to be comfortable, simple. So when you want to make a space comfortable, see to it that all the services are there and you can relax then, you know. And then of course the idea of beauty is an overriding factor. But yeah. So all these things are required, okay, at the ceiling level, at the wall level. And yeah, with this we end this class, okay, since this we could have finished last time, but anyways, so I can start with a new PPT. It's just 2:37. Give me a minute. Don't save. 1 second. I'll open that PPT. Yeah, can you see the PPT, guys?
Yeah, we can see the
Yes.
Yeah, great. Uh, I shall take the lecture for till 3 o'clock, okay, 3:10, and whatever we complete, we'll complete. Okay, so we finish with the systems, the air conditioning systems. That was what happens in the AC plant room and how the physics of the cooling happens, okay, and how the heat dissipation happens. From there, we understood the components that is there. So, what is the compressor? What are the different types of compressor? Condenser क्या है? कैसे बनता है? What materials are being used? Okay, so that was the first lecture. Second, we finished with all the different systems which comprised of central and unit. So in central, we studied two systems, which is chill water and direct expansion. While in package, we studied window split package. Okay. Now coming back to the centralized, where AHU, zoning and the ducting is another important part of the. That is another reason why this system is so costly. It just doesn't happen कि एक floor पे किया और काम खत्म हो गया, because this is like over and over and over. You have to do this in centralized, and you have like a high rise building or a very long building. You will have to then plan for each space, and the ducting will have to be so important. And then how do you take the water? And all that planning will have to happen, right? So this is what we are going to do here. So this is where we study about AHU. I wish this was a full screen. Hmm. But anyways, because in full screen when I do the animation ना आपको एक एक पे मैं I can focus on that and I can tell you. But anyways, low pressure, low temperature refrigerant which chills water to air. Okay, so ये आपको cycle पता है. Okay, understand what happens. This is happening at the basement level, and I'm again just refreshing. So every PPT will have a refreshing start this thing. Okay, so that you are comfortable with the idea, because it's quite complex. थोड़ा सा है dry. 3 air conditioning cycle we studied. One was within the cycle, that is within the basement, compressor to evaporator वाला जो refrigerant घूमता रहता है. Then the refrigerant cools the air or water which is taken to the space, and then finally the condenser which is very hot, which I need to cool, so I will take the water to the cooling tower. So the 3 simultaneous cycles happen for the magic to happen, है ना? Or the physics to happen. That means the transfer of hot air from your place to the outside, to the terrace, ये ऐसे जाता है. Hmm? And these are the different things that happens in the air handling unit. Hmm? So what is air handling unit? HU is a place where air is cooled, filtered, dehumidified and controlled. Hmm? Where is this air handling unit? It is at each floor, okay, which I showed you in that diagram, where cooling is to be provided. So even if you have 44th floor, and you say that 44th floor is a recreational plaza, it's a tall building and I don't need any kind of a cooling there, so you don't provide AHU there, simple. But what you will need to provide, and if you have floors above which are still to be continued having the cooling, then at least that जो cut out in the slab with the walls around it, so that people do not fall. I mean, लोग तो नहीं जाएंगे, but किसी का पेन रोल होके जा सकता है, किसी का wallet गिर सकता है. You know how it happens. So you need to protect that slab, and also it look very funny if you can see the chilled water pipes going all the way up, and you are in a garden. कैसे लगेगा? So you know what to do. Okay, architecturally you can take care of that. So that will happen at each floor. How is air handling unit done? It is basically a quite large place where HU machinery is kept at the center of the room with enough maintenance space around, along with the storage space. Storage space in the sense, again, यहाँ पे भी you will require certain fans, okay? You will require certain pumps. You will require water to be taken out, because यहाँ पे भी condensation होता है. Hmm? Wherever you have evaporator coil or a chilled water coil, the water will condense and it will get collected and it will need to be drained out. So you यहाँ पे भी you will have to have the drain. Requirement for each air handling units is this, okay? An external wall of the building, as it draws about 25% of the fresh air in the system, which I showed you in the last PPT. It needs acoustical treatment because you have a fan, okay? Dehumidifiers hota hai, and overall the fans are pretty large, right? Because you have a large area where the fan is throwing, and imagine 1200 RPM का fan लगाया आपने वहाँ पे, कितना आवाज करेगा वो. छोटा सा अपना ceiling fan in a room makes so much of a noise. Have you ever felt that noise? I mean, आज अगर नहीं किया है तो just feel it. If you're sitting in a room with a fan on continuously, just shut it off. एक शांति होती है. You get a very peaceful kind of thing. Imagine a 1200 RPM fan. It's going to roar there. It needs drainage as the condensation occurs. Ducts either within or nearby to facilitate supply and return chill water pipes to AC plant room. So generally, as I said prior, if I have a AC plant room, I will want my AHU to be right above the other. That would be the ideal situation. It's like having toilet one above the other. That would be the ideal position. But suppose by design it is not possible, or whatever. In such a scenario, wherever the AC plant room, you will have to see to it that the duct is there from which the chilled water is coming, and then that chilled water is routed into your AHU, and then only the chilled air can happen. So all that Jamila, you will have to you do that or plan that if AHU is not above your AC plant room. So ये एक sensitive point hai for designers, and especially when you plan your building, you need to keep this in mind. Okay, it could be done. Hello, I'm not saying that it cannot be done. It could be done, but it's that you require special thought for it. Fire safety, yes, definitely, because it's full of machinery. Anything can go wrong, and you need to have complete fire safety for that. So yes, each you should be ideally one above the other and structurally sound, because again, 1200 RPM fan, it vibrates. Okay, so I need vibration isolating pads. Okay, my slab has to be designed to take the, otherwise you know that vibrations can be passed on, like what we studied in the acoustic last year. So sound is फिर भी ठीक है, but when it's a structural actual vibration, it's quite high. Okay, so we don't want that to happen. So these are the air handling units, where it is, how it is, what are the requirements, and this is how it works. Simple, eh? Okay, so this is the return air. Can you see this? It's a very nice diagram. Okay, this is the I hope you can see my arrow here. Okay, so this is the return air. Unfortunately, it does not give me the option of drawing on this unless I go full screen. So I cannot draw on it. And full screen आपको दिखता नहीं है. So anyway, so यहाँ से आपका return air आता है. Okay, so imagine from here the return air is coming all the way up here. To this return air, you also add the 25% fresh air, है ना? Because वो तो बाहर का air है. It will have pollution, it will have heat, and all that air is, but it has oxygen. So you add that air to the return air, and that thing is passed over your exhaust return fare. So this is where the sucking happens. The entire force of the air where it is sucked in is happening at the back point of it. Okay. Obviously, what did I tell you? This is the throwing part. This is the sucking part. So this is how it will get the sucked in. Then it is thrown out. Uh, the exhaust return air फिर कहाँ जाता है? थोड़ा सा exit हो जाता है, थोड़ा सा so you allow a little bit of the air to get lost. Otherwise, imagine 25% air keeps on adding, there will be too much of pressure there. So it needs to be little bit released also. So थोड़ा सा release भी करते हैं. Now this comes here, and this is where your mixing of the air happens. Okay, then you have your cooling. So this is, so here what they've shown is they are allowing the outside air here. I will not opt for this because this has lot of impurities. But अभी तक कोई भी filter media से pass नहीं हुआ है, तो it's okay. If this air is coming in, it is still getting filtered here. So this is outside air damper, which allows the air to come in. Then you have, so यहाँ का air and this air is getting mixed up. Then you have something called as a pre-filter. Pre-filter is nothing but it basically blocks the major kind of visible particles, okay, on this filter, okay, which can be a dry filter. Then it is passed on the final filter. Now, final filter are of such variety that they can even clean the bacteria. Say you are planning this cooling for a hospital, and where you need to see that the air that they receive is spick and span, okay, absolutely pathologically clean air. Now in such a scenario, you would have to this final filter, जिसको हम कहते हैं, and I'll tell you about the filters in the next lecture. Then there is a high quality of filters. They are known as a HEPA, 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 whatever filters, which clean the air to the max. Okay, they are highly costly, but they are most amazingly effective. So this is how you will have, so you have primary, you have secondary, final filter. Once the filtered air comes here, it passes over the cooling coil. The cooling coil is nothing but the chilled water that is coming from the AC plant room. So from the AC plant room, the chilled water comes here, it circulates. And why the circulation? Again, because you are providing more surface area over which you have this air getting passed over, and then it you have a supply fan. Okay, in this case they are utilizing this. Okay, I have seen systems where they only utilize one fan. So then they have a supply fan. Okay, and then it is passed over the humidifier. Now humidifier can be of both types. They can be dehumidifier or they can be humidifier, depending on which climate you are designing your AC. So if you are in Rajasthan, you would give me humidifier where I want to add humidity to an extremely dry air. Okay, while if you are planning in Mumbai, you will not think of humidifier. Okay, in fact, you will think of dehumidifying the air. So that's how the difference will happen. Okay, And then you have sound attenuators where you quieten the sound, so you have those acoustical panels placed there, and then finally only the air moves out. Okay, so that's how you will have your entire HU planned here. Okay, any questions here so far, so forth? Anything that you didn't understand? So these are the components that happen at the HU level. HU is at every floor. So that means if you have 25 floors, you will have this kind of a configuration in a 25 floors. That means कोई इतना पागल नहीं है कि एक लाइन लाके इसको असेंबली करेगा. You get an assembled box, okay, of different tonnage. वो आपको लाना है, and you have to put it up at 25. So if you have 25 floors, you will have 25 HUs. Any questions here, guys? हाँ तो हाँ, ना तो ना, जल्दी बोलो.
Nah, no.
Okay, great. And then we go ahead. Where was I? Yeah. This is the same, different pictures. Okay, same thing. So that was to show you the actual thing, but this is the actual box. और मैंने बोला था ना, generally there is only one fan, so that's how it is. Okay, there is only one fan. कोई दो fan नहीं लगाता है. Too costly and too noisy. तो यहाँ पे वही है. So what happens? You can see this air, kind of indicative air of a brown color. Okay, actually it's not brown. Okay, so anyway, so this is outside air plus return air. So this part of the fan sucks it in, and then it throws it out, and then you have the rest of the thing. So you have a heating. So this diagram I put it here so that I wanted to show you that in foreign countries where you have equal requirement of heating and cooling, you would use both. And again, as per the sensors, as per the need, as per the temperature sensing, the coils will be on and off. Okay, so that's how it will be. Suppose this is cooling time is required. It's a summer time, and I don't require heating. Heating में कुछ नहीं होगा. There will be just set of coils. Okay, the air will just move over them without getting affected any which way. Okay, so that's how the thing. Now, if it's a winter time, and I need heat air, I mean, sorry, hot air, sorry, then I will have this thing on. That means the hot water will be coming into it, over which this air is passing. It gets heated, and I get a supply of a nice warm air where the temperatures are freezing in the room. So that's how this AHU gets converted into the heating as well as the cooling coil. So this is what actually happens in US, UK, and anywhere where you have very high temperatures. Okay, Russia, Canada. Okay, and then the set of the same thing. So you then have your bag filter, or you have your pre-filter, and then you have inlet damper. So what are the dampers? Dampers are the place which kind of motivates the air to go into a certain direction. Okay, there are fire dampers placed here at the start of the duct. Generally, as we keep saying to you, that all MEP rooms are basically the prime source of fire. है ना? That means the chances of fire occurring here are 75% more than happening within a room, a normal room. Okay, because of high electrical stationary and mechanical moving parts, which constantly happens, and anything can go wrong anytime. So if that fire occurs there, what is the first concern? It should be basically the smoke should not go out. है ना? So how do I stop the smoke? First of all, I seal the room. So my door has to be seen that it is not allowing the smoke to come out. That is one thing. Second is the duct is the usual way the smoke passes. So the other thing that I have to take care of is that I seal the ducts, and dampers work that. So if you go back to sixth semester in the no, we didn't do dampers there. Sorry, dampers will happen here only. Where did I do the dampers with some other? I think it was the fifth year. Sorry. Um, okay, so yeah, so the dampers work in the duct. So these are the other fire precautions that you will take besides your normal fire thing that you were doing, what you studied in the third year. Okay, so these are because smoke will be easily transferred through the ducts. These are becoming like a passageway for the smoke to travel. So we don't want that to happen. So the inlet damper is that damper. Okay? Inlet of air into the space. Okay? Any questions? Okay, The other types of coils used is the direct expansion coil. It is built same as water coil, but instead of chilled water, it houses the refrigerant. Remember what I said? AHU जब आपको refrigerant use करना पड़ता है, तब उसको हम direct expansion coils कहते हैं. While chilled water pipes are chilled water coils meaning normal water उसमें आता है. So that is the reason why I asked you, did you understand when will AHU be used in a direct expansion system? And in the direct expansion system, it is not the water that is traveling, it is the refrigerant. That is the main difference between the chilled water and the direct expansion. Please understand this, okay? If you have any doubts, please ask again, we can clarify it. Okay, these are the basics of HVAC system. So you have the heat ventilated room. Again, the same thing what I showed you in an animated form last time. Unfortunately, आज कुछ नहीं हो रहा है, but anyway. So this is my ventilated room where I want the air to be chill and nice and comfortable and filtered. तो इसका जो heat है वो travel होता है. It comes here, travels over here, filters, coils, ठंडा पानी, and then it comes and comes back. So this is one cycle. This is the other cycle, and this is the third cycle where the cooling tower and the chiller नहीं होता है. Chiller in the sense complete machine, huh, guys. So this is another confusion that is always there in the minds of the students, because in the market, okay, this is the market I'm using. When you go out in the and practice as an architect, market में when they say the chiller, na, that means the set of four things. Set of four. When I say chiller, it means it will have evaporator, condenser, compressor, and the expansion one. सब कुछ होता है उसमें, उसको chiller बोलते हैं. Okay. For some strange reason, they call that as a chiller. Okay. So imagine this part to be the condenser. Huh? तो ये condenser आपको cooling पे जाता है. Otherwise, the confusion will be, अरे chiller को क्यों condenser पे, I mean cooling tower को लगाया? No. Right? So this is how it is. And in the heating season, when I require the heating to be done, I will be supplying water to the coil. So this is the difference, or this is the advantage rather of having a chilled water system, where I can use this boiler water also as well as the cooled water also. Okay? So this is how it is done. This is how the basic heating and cooling is done simultaneously. So one way, the question is, somebody asked me last year, I guess, maybe, I don't remember. So that means I will need a cooling coil here also. Why can't I have the single coil working as cooling as well as heating? A very valid question, okay? You can do that. यहाँ पे एक wall लगा दो, जिसको आप सेंसर लगा दो. जैसे जैसे वो हीट सेंस करेगा, the wall will change and will only allow that component of water to go in. So then I'm controlling. I don't need two panels which I showed you in the previous this wala, where I'm showing you that this is the heating wala coil and this is the cooling wala coil. Why give? And so much of space is gone, so much of kharcha, so much of maintenance, everything increases. So yes, you can definitely do this. So this pipe will come here, this pipe will come here. You put a mix. अपना shower में कैसा रहता है? You have a mixer, ना? बस वैसे ही. So you put that and you allow only the required one to go there. And how will you control it? Do you think at 25 floor people will go and manually control it? No. You have sensors and they will do it. A very nice diagram which kind of shows you the chillers, AHU, RC. Again, chillers. What is chillers? Chillers is something below. है ना? So please don't get confused by the word chillers. Chillers means all four things together is known as chillers in the market. Okay, AHU is at every place and RTU is return unit. RT is return unit. So return unit is nothing but your cooling towers from where the things will come down. So what they are trying to show you the connection is that cooling tower is connected to the basement and AHU is connected to the basement. But AHU is not connected to the cooling tower. The moment you show me that, you get a big zero. So this is how my entire system is planned, okay? And this you can see is a VRV system, okay? So VRV system में बहुत सारे units अलग-अलग होते हैं, and that can also function at a separate level, okay? Again, which is trying to show you that both things can happen, cool as well as hot, okay? When the system reverses, opposite hota hai, okay? When the system reverses, opposite hota hai. In the sense, when this is the winter season, okay, it will be the hot air that will be supplied, and the cool air will be coming out. But when it is a cooling season, the supply is of the cool air, what you are seeing here, okay? So that's how it is, okay? So don't get confused by these different diagrams. I'm just trying to tell you that in foreign countries, or especially where you have this diametrically two opposite side by side, and I need both heating and cooling, you will have the same equipment working for the advantage, so that I can save space, I can save money, I can save management, maintenance and everything. Hmm? Filters. Coming back to the filters, we talked about two filters. One was the basic filter. Basic filter is nothing but what the filter you have in your own rooms. They are known as a dry filter. Okay. So the filter is basically nothing but a very fine kind of a material which do not allow the finer particle to pass through. Sorry, the larger particles to pass through. So only the air will be able to pass, but उसमें सारी जो physical impurities है that can get stuck to the basic filter, okay, which can be done of straw, it can be done of feather, it can be done of fine wire mesh, anything, okay, and then the air moves in. So filters form an important part of AC, as one of the criteria of conditioning is providing clean air. Guys, if it is enough, please tell me. I'll stop. I know this is, and it is still lengthy. We have not yet finished with AC. There is one more lecture on AC. If I finish this today, fine. Otherwise, two more lectures. Filters form an important part of AC, as one of the criteria of conditioning is providing clean air. It's not just about giving me good temperature, है ना? तो I can put a nice क्या बोलते हैं वो cooler, क्या आता है ना, cooler something where I get a cool thing, but it gives me lot of humidity, and I'm not comfortable. After some time, it is absolutely horrible to stay in that room, and I have to open up the windows. Cooling तो वो भी देता है, but does it give me comfort? No. So filters, in fact, if you see, most of the companies focus on filters, okay, though it's a very small part of it, because of the sick building syndrome, and this you might have heard, seen from someone or even from your own parents, that someone will come and complain के ऑफिस में आज इसको सर्दी हो गया, कल मुझे होने ही वाला है, और उसको होता ही है, because of the same air being circulated. So the same bacteria, if somebody sneezes and if it's contagious, every one of you is possible that if your immune system is not fine, you will have problems. So yeah, cleaning is of utmost importance, okay. Is achieved even to a level of bacteria-free air. Filters should be placed ahead of coils, fans, etc. क्यों? Simple है ना? Clean air should go over the coil. Why ganda air should go over the coil? ना तो coil पे problem होगा. So I will try to push clean air over the coils, because that's a metal. Metal can get easily coated with all this kachra, so that the air entering the H unit will be clean and will not deposit on different components of the unit. Simple, है ना? Filter selection requires consideration of the kind of air cleaning service. Okay, first the cost of it, cleaning, and the replacement cost. So you say you are planning for a hospital. Hospital requires maximum cleaning. In fact, hospital, we will do hospital planning in final year, but hospital planning का AC system ही अलग होता है. Okay, it's completely different. Okay, and it's quite fun. Okay, in fact, if you see, during this COVID last year, I think 2020, there were many webinars on hospital planning. If you guys were, if you were aware of these things, you would have attended. It's really fun to understand. It's very funny because they realized that they could not put COVID patient in any. तो कितने सारे hospitals were available. Why do you think there was only certain hospitals where they were able to keep the COVID patient? Not because they had ज़्यादा है जगह इसके लिए हमारे पास आओ, ऐसा नहीं है. Because they had a good air conditioning system. That was the reason why COVID patients were kept in a certain area. Okay, because COVID is पहले तो ये डर था ना, it was spreading through air. बाद में पता चला. But still then, people didn't want them to be in touch with people, and they wanted to have a clean air. So I'm not just speaking about the COVID. COVID is not, I mean, there have been cases where even coughing and the passage of bacteria through air can, create problems for the whole community around. So in such a scenario, having correct air conditioning system in hospital is of prime importance. So yeah, these are some of the things why you need to have the filters, and you can see the wide arrays of the numerous pick you can take from all kinds of filters. We'll go one by one. Hmm. Okay, please take a snapshot of this. Okay, it will tell you everything. Quickly, I'll just go by. Okay, this is fiber wala fiber, and I don't know why this is happening. Okay, I think this is again the PC problem. When I was showing this to you last time, the previous one, okay, every box had its own. इसमें मुझे सब ऐसा adjust करना पड़ेगा, which is so irritating, and it's actually adjusted. Anyway, so you can see fiberglass air filters. Fiberglass is that fine material. We also use the fiberglass for acoustic reasons. Okay, disposable, affordable, lowest straining ability. सबसे basic ये है. हाँ, इसमें से सिर्फ बड़ा particle ही रुकता है, बाकी सब जाता है. हाँ, so you get all kind of dirty air. Then you have a protection in your AC system. If you are using this type of air filter, you might still be prone to prone to respiratory issues. Okay. Then you have pleated filter. I hope I have the pictures. No, I don't think I have. I have. So these are the pleated pictures. Okay. This is the corrugated. Sorry, इसमें pleated नहीं है. Anyway, pleated is like a pleat. हम साड़ी का pleat लेते हैं ना वैसे. So it's like polyester fabric again. So fabric is better than fiberglass. It allows only certain particles to pass through, but yet it's not so effective. But better than fiberglass. Definitely better. Effective in filtering dust and other pollutants. Choose these with more pleats because they will offer better filtering. ज़्यादा pleat रहेगा ज़्यादा filter होगा. Washable is something where you can wash the filters and reuse them. So sustainability wise and environmental friendly wise, these are long lasting, lesser wastage production, and economic, because you are not every time paying for a new kind of a filter. Hmm. So this is your washable. Your electrostatic is very simple. You remember the cathode anode wala exercise we studied in 8th standard, 9th standard? Simple. You have two electronically charged plates. One is positive charge, one is negative charge. When the air passes in between, all the dust particles are charged and they will get attracted to the opposite poles, and the air will move ahead in a clean manner. Supposed to be good, okay, quite high filtration possible. Charge the magnetic dust and airborne particles, then prevent them from being distributed in your home. Some filters of this type are washable, while there are also those that aren't. Okay, HEPA filters, high efficiency. Particulate air filters are best for people with allergies. Okay, and prone to respiratory difficulties. 99.97% effective in screening contaminants. So yeah, that effective. That's why I say it's completely used for hospital. UV filters, again used in hospitals, uses UV rays to kill bacteria and viruses, but less efficient in screening and dust and other pollution. It's just passing the light ना, वो आपका किधर से dust को screen करेगा. So you will require a HEPA filter, and then you want to go for a higher pathological killing of the bacteria, you would go for UV filters. So yes, these are the picks. You can pick your filters. Fortunately, as an architect, I have never had to pick any of the filters. I only order an AC unit and it comes at my place. But this is some as a general knowledge. Hmm. A very old picture of trying to show you what was the initial system, which was very funny. You can actually see this. This is very funny. This is the way they used to add humidity. There used to be actually shower happening here. Okay, so there used to be a water running, trickling down, and then being collected, and then again being pushed up. All that thing used to happen, and you can imagine the size of the filters. And this guy is standing here. Okay, and so you can imagine the size of the box and the amount of air that is being passed over it. It's tremendous. And he's actually cleaning each one of them separately. Quite funny. And we have come a long, long way in air conditioning. Okay. Yeah, this is what exactly I was telling you. So this was how they used to do it. See, this is the picture. Actually, shower cubicle lagta hai, where you can actually stand and have shower as well. Mm. So this was how the obvious plumbing facility was required in those olden times. Today we have fantastic humidifiers and dehumidifiers, thanks to the technology, thanks to the new materials that have come out. Okay, so all that thing is now included in your AHU, and you get a very nice, clean, safe unit which encompasses everything, which I showed you a picture before. Humidity control is done in this way. So you have air conditioning. Dehumidification increases the total pressure or compressing the air. आपको पता है ना? If it is loaded with water pressure, water vapor, air tends to get heavier. Okay, it tends to settle down. So we add desiccant dehumidification, also known as a chemical dehumidification. You don't need to remember this. This is only for your information. And now in this method, you add a desiccant material, or basically a drying material. Do you know any drying material? Any one of you? If you are observant enough, you will know. Where do you see this kind of a material being used in a day-to-day life? Normal day-to-day life. Anyone?
Silica.
Yeah, but where do you use that? You guys don't remember opening a medical medicine wala bottle and अंदर से एक थैली निकलता है छोटा सा. That is your silica. What is the actual chemical name? I don't know. But that is a dehumidifier. Imagine if there is a little part of humidity in those pills, you know, they'll become sticky, and it will have fungus on it, and so it's very dangerous. So you need to keep those bottles free of humidity, and that's why you insert those dehumidifying chota chota silica gel, silica, shit, I forgot the name. Anyway, that is what you insert there. Mechanical dehumidification, also known as a refrigerative dehumidification. It is a method of removing humidity by cooling the air to condense the water vapor. Bapre. Okay, so then all that air, water vapor, which is present in the air, उसको आप इतना cool करते हो कि उसमें से आपका पानी निकलता है, and that is then taken away. But then it's a waste of too much of waste of energy. But then the water can be reused definitely. So it's either way, people opt for different systems and do it. Fortunately, we don't have to deal with this. These are how the different sensors are used. I'm just trying to tell you the smart technology, and for you to understand how a smart technology can save lakhs of rupees yearly if you apply it in a building. Okay, because just see this. Okay, DP sensor filters. Okay, तो यहाँ से आपने sense किया, ठीक है? This is censoring it. Okay, this sensor is then attached to n number of numerable sensors that are there. Okay, and that's how your humidity is controlled. So you have temperature sensor, heating coil, temperature sensor, cooling coil. SP sensor is the discharge. Okay, that is how the refrigerant is speed, उसको बोलते हैं discharge. Okay, or a sensor. You have temperature sensor. What is the temperature of the refrigerant when it is passing through the coil is also sensed. If the temperature is going down, the compressor will increase the speed so that the faster movement of the refrigerant can happen and the faster heat is taken out. So immediately the moment the temperature is shown going high, यानी कि suppose requirement is of 4 and it goes to say 10, the compressor का speed बढ़ जाता है. So all that is so finely related with each other. You have supply dampers. So immediately the supply dampers, somebody presses a remote in the room and they realize that I need more air to come and I require more cooling of the air to come. Okay, so immediately the dampers will open up more, allowing more air to come in, so the more speed will be there, more temperature can be then maintained. All that is done. So one is related to the other in a numerous possible manner. Okay, you have discharge dampers, you have fan control panels, you have control valves. On every coil you will have a control valve because you need to control the flow of the refrigerant or the chill water or the duct agar hoga to air, यानी कि damper control. Everything, all elements will have to have some kind of a control so that the flow can be maintained. And it is these valves which is actually giving you the option of going from 18 degrees to 24 degrees. Yeah, And half of them, believe me guys, even I don't know, okay, because they are too technical, they are too mechanical, they are too electrical, okay, uh, for us to even handle that, right? So but yes, these will be very important for an IT engineer guy who will come to do your software business, to arrange all these cells or sensors on your BMS system, which is your building management system, which we'll do in the final year. But these are the systems which will man your building, where even if the security panels are not there, the people are not there, buildings will work on its own. It's automated system. Hmm? So any questions till now, guys? Hmm? So if not, we'll go further ahead. So we talked about zoning, right? And we talked about how can then I control my separate areas, and that's where the fan coil unit comes in. So all of you, I'm sure, when we go out for study trip, you guys have been lucky to have 3 study trips till now, or maybe 2, I don't know. So you guys were lucky to have study trips where in today's day and time, they give you a card. There is not a key to the key नहीं होता है आपके room के लिए. They give you a card. Now the card has double function. One is it opens the door for you, and the second is the moment you insert the card in that slot, okay, the electricity comes on. Mm. Now when you put on the electricity, automatically now your AC is working. That means if two people are staying side by side, okay, okay, they are staying in one room, say 3 of you are staying, and another room, another 3 people are staying. Now one set of 3 people has to go on one side and they leave early in the morning. They will shut off the light, they will go. So does that mean that the first set of people who are staying still there, because site pass mein hai, they will go aram se, will they not receive the electricity or the HU or the AC? No, na, they do get. That's where my FCU comes in. It is still centralized, but I can completely control because of this fan coil unit. What is it? Let's see. So these are some of the questions that comes across. What is a fan coil? Where can it be? Is it a unit? Is it a unit AC system or a component of an AC system? How is it useful and where it should be? Okay. Answers भी यहीं पे है. What is a fan coil? It functions like a fan and a coil. Okay, that's why it functions like a separate AC. Where it can be used, usually where separate spaces needs to be air conditioned. It is a component of the unit system or a component of the centralized system. It's a centralized system, not a unit system. Hmm? It is generally placed in the area to be conditioned at. So if it is a room, I will place it at the room level. If it is to be a small conference, then I'll place it at a conference level. Okay? And how is it like HU? Because what happens at the HU में क्या होता है? You don't do actual cooling of the refrigerator. Na? You just get a supply of chilled water and you have a fan, and then all the set of filtering and blah blah blah. Okay, same thing happens here. So it's like a mini HU placed at the room level. That's it. So क्या होता है? You have a set of coil there. Should I wish I can draw here? I think I'll continue this next time. I'll finish this, then we'll continue this next time. I really want to draw it out for you. Maybe if the next diagram can show, maybe. No. So yeah. So a chilled water pipe from the AC plant room to FCU. FCU is nothing but fan coil unit, just like AHU, है ना? AHU में नीचे से पानी आता है, goes into those coil, जिसके पीछे एक fan है. Fan is blowing air over the chilled water, and chilled water का energy transfer होके तुम्हारा air ठंडा हो जाता है. That's it. Exactly the same thing will happen at the AHU, but on a mighty smaller level. Hmm? Here you are thinking of supplying the whole area, while here you are thinking of supplying only a small room where you are staying. It has a cooling coil just like AHU. It has a fan just like AHU, okay? And then I can't see because it's in white. Okay, so with this we finish the lecture today. I'm not going to continue because this is really funny. I would really like to draw over it, but I can't. It doesn't give me any option, and there are a lot of slides remaining. So we'll continue with this next time. Any questions so far, so forth, till now? Forget about the fan coil unit, okay? Till now, till here. No? You understood everything? Very good. ठीक है then. Bye. See you next time. Next time I'll take the lecture from